Howdy, Mutsweneng. Greetings, welcome to another ramble with me. Paper one from the department from last year. So excited to be sinking my teeth and my fingers and my nails into this at last. But yes, sorry, wow, derailing of the intro. We are busy with the department's paper one from last year, November 2023, the final exam. Yeah, let's get in. Did I say we're doing question 1.3? We're doing question 1.3. Given 2 to the power of m plus 1 plus 2 to the m is equal to 3 to the n plus 2 minus 3 to the n, where m and n are integers, determine the value of m plus n. Okay, so I mean, what I immediately want to do is to extract the common factor on either side, just so we go from having, the variables repeating to just having them in one place. So in order to do that, I'm just going to rewrite 2 to the m plus 1 as 2 to the m times 2 to the 1. Okay, and similarly on the other side, 3 to the n plus 2 is the same as 3 to the n times 3 to the 2. So now we can see that, okay, over here, we have a common factor of 2 to the m. So we can factor that out. In the first term, I'll just be left with 2 to the 1. In the second term, I'll be left with 1. And then on this side, on the right-hand side, we have a common factor of 3 to the n. And in the first term, I'm just left with 3 to the 2. And in the second term, I'm left with minus 1. Right, so let's just simplify this quick. So over here we have 2 to the 1, which is just 2, plus 1 is 3. And here we have 3 to the n times 3 squared, which is 9, minus 1, which is 8. Okay, let me just tell you right now that I have no idea where this is going. We are trying to find the value of m plus n. So that makes me feel like I want to ultimately... Oh, yeah, what? Oh, I think I see where this is going. Oh, okay, I see where this is going. Okay, so, right, so what was throwing me off was I was thinking, okay, I want to end up with a something to the power of m plus n, right? And maybe do something clever there, which, so I was just focusing on these exponents, and then I was confused because I was like, the only way that I can think of that will get this to this side is if I do a division, but then I'd have to minus the exponents. But I wasn't even thinking about the fact that these are different bases, so that whole plan is just a flop. Yeah. So what then sprung out at me and beat me up is the fact that, well, 3 is a power of 3, it's 3 to the power of 1. 8 is a power of 2, it is 2 to the power of 3. So I am going to get this 8 onto this side so that we can express the left-hand side as a power of 2, and get this to the other side so that we can express this side as a power of 3. So we're going to divide by the 8, okay, so that these two can cancel, and then we're going to divide by the 3 on both sides so that these two can cancel. Okay, so now we have 2 to the m divided by 2 to the 3, right? That's what 8 is. Sorry about that. And then here we have 3 to the n divided by 3 to the 1, right? So this is 2 to the m minus 3 using our division rule. And this is 3 to the n minus 1. Okay, how does this solve anything? Oh, it doesn't solve anything. Determine the value of m plus n. Oh my goodness. We didn't need to do all of this. Okay, we didn't need to do all of this because really the answer was right under our noses. Sometimes Okay, I'm not gonna judge myself for jumping into things because literally this is how my brain thinks. My brain thinks from one banging of head against a wall to another banging of head against a wall. Like, I really struggle to just sit back and put the pieces together abstractly in the vast space of my mind. Like, I have to scribble, I have to scratch out and scribble again. So apologies to whom it does offend, including myself, because I offend me. Anyway, so the revelation here is that, okay, this is 2 to the m times 3 to the 1. And 8, as I recently said, is 2 to the 3. And this is 3 to the n, right? So the only way that these two statements, these two expressions can be equal is if this is in fact equal to this, and this is equal to that, right? So therefore, m must be equal to 3, and n must be equal to 1. And therefore, m plus n would be 3 plus 1 would be equal to 4. Yeah, okay. Interesting dribblerations. Right, let's just double check our numbers. So m equal to 3, n equal to 1. Let's see if that does in fact work. So that would be 2 to the power of 3 plus 1 plus 2 to the power of m. So that is 24. Okay, and then we have 3 to the power of n plus 2 minus 3 to the power of n. Okay, of course this little calculation doesn't prove that these are the only solutions. There we just have to trust that our mathematics was on point, but that's satisfactory enough for half Magnan. Okay, let's see. Question 1 point something, 1.3. 1.3, m plus n is equal to 4. Right, they have two ways of going about it. Right, okay, so the first approach is what we have done here. The second approach oh, interesting. Okay, so for the second approach, they got to the place that, so remember when, okay, I'll just carry on from here. Okay, so they did the switcheroo thingy-wingy that I attempted to do, right? So we divided by 8 times 3 so that the 8's cancel here and the 3's cancel here. So basically move everything that's related to 2 to one side. So that would be 2 to the m over 2 to the 3, and here we'd have 3 to the n over 3 to the 1. So then this is 2 to the m minus 3, which is equal to 3 to the n minus 1. And so essentially the question is, what powers do 2 and 3 share in common? And the assertion that they make is that the only power they have in common is 1. Now, I mean, that's bold, and it makes sense to me in my brain, but I wouldn't be completely satisfied with that because, you know, I can't just think about m and n being natural numbers or integers. Like, I also need to think about, you know, if m is equal to pi and n is equal to something else, you know, like, is there no weird irrational number or even a rational number? Two of them, you know, that I can put in here and another one in here, and somehow these two end up being equal. Like, I don't know, man. I don't know. Well, I guess it comes down to, okay, yeah, it's fair. So if we're to just ignore the funny looking exponents for 2 seconds, so if we just have the graph of y is equal to 2x and the graph of y is equal to 3x, what am I trying to show? I'm trying to figure out when are they equal, when do they intersect? And really the only place they intersect is in fact over here, right? They don't intersect anywhere else. So actually, yeah, never mind my reasoning, eh? Right, so this is y is equal to 2x and y is equal to, not 2x, 2 to the x, y is equal to 3 to the x. So, okay, that's fair. So the only way that these two could be equal is if the exponents are both 0, because that's where these two graphs intersect, is when the exponent is equal to 0 and the output of the function at this point is 1. So anyway, so yeah, so their solution says, well, m minus 3 would need to be 0 and n minus 1 would need to be 0 in order for these two to be equal. So then m is equal to 3 and n is equal to 1, and m plus n will again be equal to 4. So that's an interesting way to look at it. My brain was not switched on. Little brain. Okay, perfect. Thank you for tuning in, and as usual, I hope it's been useful, and check you another time for another ramble.